Here proving some property related modulus, properties of modulus. Three properties I have taken. Properties number one, mod of z1 multiply z2 is equal to mod of z1 multiply mod of z2. This is we have to prove. Number two, mod of z1 by z2 is equal to mod of z1 by mod of z2. This is we have to prove. Another one, mod of z1 plus z2 whole square is equal to mod of z1 whole square plus mod of z2 whole square plus 2 into real part of z1 bar z2 or 2 into real z1 z2 bar. So any one from these two you can take. So I have first proved the third one very complexly, and I have followed a very simple way to prove this. Take z1 is equal to a1 plus iota b1, z2 is equal to a2 plus iota b2. So z1 plus z2 is the sum of the real parts and sum of the imaginary parts. Now mod of z1 plus z2 whole square is equal to b1 plus a2 whole square plus b1 plus b2 whole square. This is by definition of modulus. So if we go through the formulas and rearrange this, then it will become a1 plus a1 whole square plus b1 whole square, a2 whole square plus b2 whole square, and last this will come 2 into a1 a2 plus b1 b2. So now this is equal to mod of z1 whole square, this is equal to mod of z2 whole square, and this is, if we try to find out, we have to take multiply z1 multiply z2. So if we multiply z1 multiply z2, the problem is that we will get minus relation between these two terms. So we will take a bar sign on z1 bar z2 or z1 z2 bar. So for each cases we are getting that this comes in the real part of the z1 bar z2 or z1 z2 bar. So we just write this, and we have the required formula that mod of z1 plus z2 whole square is equal to mod of z1 whole square plus mod of z2 whole square plus 2 into real part of z1 z2 bar or real part of z1 bar z2. So now we are going to prove number one. This is given that mod of z1 z2 so if we put, we have to multiply z1 z2. So z1 will be a1 minus b1 b2 plus iota a1 b2 plus a2 b1. So mod of it will be, you can take full square also. So under bracket I am taking whole square form. So this will be a1 a2 minus b1 b2 whole square plus a1 b2 plus a2 b1 whole square. And I just wish to inform you that if you have not subscribed this channel, then subscribe this channel. You get such kind of videos per day. Thanks for watching. So now I am focusing on this that I have taken already square form. So this will come actually after multiplication. And if we go to break down it, we will get a1 a2 whole square minus 2a1 a2 b1 b2 plus b1 b2 whole square plus a1 b2 whole square. I'm just not writing whole square form, plus 2 into a1 a2 b1 b2 plus a2 whole square plus b1 whole square. So this cancels each other, and after that I'm using another line to write down this. I'm just taking common, so you can take common from these two terms. Here we can take a1 whole square and we will get a2 whole square plus b2 whole square, and from the second and third term we can take plus b1 whole square. We can take common, b1 whole square is equal to b2 whole square plus b2 whole square. So then you can take common a2 whole square plus b2 whole square, a2 whole square plus b2 whole square, and we will get b1 whole square plus b1 whole square. So if we put this, we will get mod of z1 whole square square mod of z2 whole square. So this is the form of modulus, and mod form is always positive. We know this. We can simply write down mod of z1 multiply z2 is equal to mod of z1 multiply mod of z2. So in this way you can prove the number 1. Number 2 is somewhat hard, so I am trying to prove this. Here we have to first take z1 by z2. So z1 by z2, if we take, it will be b1 plus iota b1. If we think very closely, b2 plus iota b2, we have to use a conjugate to remove the complex number of the denominator. Using the conjugate, we can very easily remove the complex number in the denominator. So if we think that z1 is multiply z3, where z3 is equal to 1 by z2, since it is very easy that 1 by z2 form of complex number can be very easily transformed into z3 form. So we can very easily take z1 z3 and take mod form, then we will get mod of z1 multiply mod of z2. And if we now put the value of z3 in place of z3 1 by z2, we will get mod of z1 by z2 is equal to mod of z1 and here it will be mod of 1 by z2. Just taking z3 as a 1 by z2. Otherwise it's very hard or tough to calculate. It will be long to evaluate. I am taking use of conjugate, and in this way I am going to do. So now we know the mod form of 1 is 1, and if we now take this in this way, that we know that mod of this will be mod of z1 by mod of z2. So in this way you can prove this. Mod of 1 is equal to 1. And another form, another equation was the another form another rule was that mod of z1 minus z2 whole square is equal to mod of z1 whole square plus mod of z2 whole square minus 2 into real part of mod of z1 z2 bar, or 2 into real of mod of z1 bar z2 bar. So this can be also very easily proved, as I proved with 3. This can be very easily proved, but here is the confusion of 1. Modulus of 1 is I have taken 1. What I have done here, I have taken the formula in reverse way. Is mod of z1 multiply mod of z2 is mod of z1 by z3. So I have used this on the above in this way. And if confusion persists, so we can go large way to prove it. If it is not suitable to accept, then we can put a large way, as I have done in the number one formula. So we can go through in this way also. So thanks for watching. Just we have calculated, and we can prove this very easily.